So we are discussing the topic 1.1, which is about the effect of the force, and we discussed the first effect, in which we discussed the Hooke's law, that force can change the shape or the size, and the second effect we discussed force can change the motion of an object. The second effect we discussed that force can change the motion of an object. We discussed the Newton's law, Newton's first and second law. And the third one, force can change the direction of the motion, that we discussed the circular motion. And today is the turning effect of the force. What is the meaning of turning effect of the force? If a force can rotate the object, force can turn the object, we call that as a turning effect of the force. So example, if you are holding a ruler in your hand, so example, this is a scale or a ruler, and you are holding from one side. So I'm holding the ruler from one side. So the point where I'm holding the ruler or a scale, that point is known as the pivot, or you can also pronounce that as pivot, or you can also say pivot. So the point where we are holding the object, that is known as the pivot. So if I apply the force on this ruler, what I will observe, what I will see, that this ruler will rotate. Like if this was a initial position, initially it was exactly horizontal, but when we apply the force, the ruler turn, the ruler rotate. So what we call this effect of the force, we call this as a turning effect of the force, that because of the force the object rotate or turn. So this is the introduction. So in this chapter, we will mainly learn and discuss about the turning effect of the force, and we'll do questions related to this turning effect. These are the learning objective. You will learn about the turning effect, the concept of equilibrium, and the concept of center of mass. So example, when we apply a force and the object rotate, we call that as a turning effect. And that is also known as moment. So moment or a turning effect of the force having the same meaning. Force applied on the object to rotate the object is known as moment. So turning effect of the force about a pivot is known as a moment. Everyday examples of a moment, example, opening a door. So when you are opening or closing a door, the door rotate about the fixed point. Like if this is a door, as you can see in the picture, a child is opening the door. So at one point the door is fixed, and the child using a lock, he's applying a force. So when he's applying the force, what happened to the door? The door will rotate. So whenever anything rotate about a fixed point, what we call that as a turning effect of the force, or in short we can say it is a moment, or a moment is produced. So opening or closing of a door is a simple example of a moment. Is it clear? The basic idea about the moment or the turning effect. So when object is fixed from one side and we apply the force so that the object rotate or a turn, we call that as a moment. Example, I have an object on the ground and I'm pushing this object. I apply the force on the object and this object move horizontally to some distance. Is this a moment? Yes or no? A moment is produced, a turning effect of the force is produced. Is this example of moment? Turning effect. Does the object turn? So we just push the object from position A to position B. Is this a moment? I want everyone to participate. Yes or no? The correct answer for this is no. This is not the turning effect of the force, because in this one the object does not rotate, the object does not turn, just object move from one place to another. So this is the effect of the force which is changing the state of an object, moving the object. But this is not the moment, this is not the turning effect, because the object does not turn or rotate. But if another example, you was having an object on the ground and you applied the force. So when you applied the force, what you observe that the object flipped, the object turned, or the object rotate. So is this a turning effect of the force? Yes or no? So this is the turning effect of the force. Yes. Why? Because the object turn or object flip or object rotate by the help of the force. So whenever object rotate by the help of force, we call that a moment is produced. But if the object does not rotate about the fixed position, we don't say a moment is produced. Is it clear? The example in which a moment, there is a moment, and when there is no turning effect or no moment. Then this moment can have a direction. How the moment can have a direction? So example, if you have an object which is fixed from one end, the point, the position where the object is fixed, what we call that as a pivot. That point is known as a pivot. And we apply the force. So what happens? This object will rotate. So when it is rotating, it can rotate in a clockwise, same like the direction in which the hands of a clock are rotating, or it can rotate anti-clockwise. Which direction this object is rotating, clockwise or anti-clockwise? When I apply the force, the object rotate about the fixed point of pivot. So which direction this object is rotating, clockwise or anti-clockwise? The new position of the object will be like this. So it is moving in the same as the direction in which the hands of a clock are moving. So what we call this rotation, we call that rotation as clockwise rotation. So moment can be clockwise or moment can be anti-clockwise or counterclockwise. So example, if an object is fixed, here's a pivot, we applied the force, an object rotate. So what kind of rotation is this? Because it is opposite to the direction in which the hands of a clock rotate, so we call that as it is anti-clock, or you can say counterclockwise. So a rotation or a moment can be a clockwise or a moment can be an anti-clockwise. So you have moment in both ways, clockwise or anti-clockwise. So because it is having a direction clockwise and anti-clockwise, so which quantity should be moment, scalar or a vector? A moment is having a direction as well. So if a quantity is having a direction, what we call that? We call that as a vector quantity. So moment is basically a vector quantity. Because scalar quantities does not have direction. They have magnitude, they have units, but they don't have direction. So losing or tighten the using a spanner or a wrench is also an example of a moment or a turning effect. Because what happened, using a wrench or a spanner, you apply a force, like here, if there is a nut, You applied a force, so you rotate the spanner, you rotate the wrench clockwise or anti-clockwise. So basically what you produce a moment. And the point where it is fixed on the nut, that point is known as pivot, because the fixed point is known as a pivot, and where we are applying a force that causes the turning effect. So this is also an example of a moment or a turning effect. Same thing, lifting a wheelbarrow. Like a laborer is lifting a wheelbarrow, that is also example of a moment. How it is an example of moment? He can drag this, he can move this wheelbarrow forward and backward. That is not the moment. But when he is lifting it, that is a moment. Example, this is a tire. So this is a fixed point. And when he is lifting up, so what happened when he is lifting it up? Which rotation he produce? He produce an anti-clockwise rotation. So as he produce an anti-clockwise rotation, it means a moment is produced. Is it clear, this example? That when he is lifting the wheelbarrow, he is rotating, and whenever there is a rotation, what we call that a moment is produced. Same way, if we are lifting the heavy object by a crowbar or a lever, that is also an example of a moment. How this is an example of the moment or a turning effect? So example, if this is even a seesaw, also having a moment. So example, this is a plank of a seesaw which is fixed from the center, that is known as a pivot. An object is placed here. If I place one object and I apply a force, so when I apply the force, what will happen? What will be the new position? So new position will be like this. So whenever the object rotate by applying a force, so what we produce a moment, or we produce a turning effect. Which direction this turning effect is produced? Clockwise or anti-clockwise? Which direction we produce this turning effect? So it is opposite to the direction of the clock. So we say we produce an anti-clockwise moment or anti-clockwise turning effect. So whenever you apply force and the object rotate, we simply call a moment is produced. But how moment can be calculated? So if we want to calculate a moment or a turning effect, how we can calculate? We use a formula, moment is equals to force multiplied by perpendicular distance from the pivot. What does it mean? Example, you have an object which is fixed from one end, the point where it is fixed, that is known as a pivot. You apply a force of 30 Newton on the object, and that is from the pivot, that 30 Newton is at a distance of 2 meters. So how we calculate the moment? The formula to calculate the moment is a product of force and distance. So what force we apply on the object? In this example, we apply a force of 30 multiplied by the perpendicular distance from the pivot, perpendicular distance or 90-degree distance. So you can see this is a perpendicular distance from force to the pivot, that is 2 meters. So 30 multiplied by 2. So 30 multiplied by 2, that's equal to 60. The force is Newton and the distance here is meter. So 60 Newton meter will be the moment. But what about the direction? Which direction this object will rotate when we apply the force? Clockwise or anti-clockwise? So this object will rotate clockwise. So we'll say a moment is 60 Newton meter clockwise. Is it clear? This example, how to calculate a moment, a turning effect. Why clockwise? Because you can see here, Abdullah Sir, Khan, that the object is fixed from this point and we are applying a force. So when we apply the force, how this object will move? It will move in this manner. So as it is moving in this manner, or new position of the object will be here. So which direction it is going? It is moving as a direction of the clock. So we say it is a clockwise. Is it clear, Abdullah Khan? Another example, we apply the force of 10 Newton. The total distance, say, was 10 meters. And this is a position of the pivot. This is where the pivot is placed. And the distance between the pivot to the other end, that is 7 meters. And the question was calculate the moment. So how we calculate the moment? The moment is force multiplied by perpendicular distance of force from the pivot. So what is the force given here? That's good, Abdullah Sarfraz. That the force which is given is 10. But what about the perpendicular distance? We take a perpendicular distance from force to the pivot. So what will be that distance? So in this example, because total is 10 and distance from other side is 7, so this distance will be 10 minus 7, which is equals to 3. So the distance from the pivot from for the force is 3 meter and the force is 10, so it will be 10 multiplied by 3, which is equals to 30 Newton meter. And which direction it will rotate? Clockwise or anti-clockwise? So it will rotate anti-clockwise. So we'll say a moment is 30 Newton meter anti-clockwise. Is it clear, this example? So simple way to work out the direction of the moment, that you can hold your, like you can use your pencil or a pen and hold from the side of the pivot and apply the force in the direction as shown in the figure, so you can work out the direction of the turning effect. Yes, we should write a direction because the moment is a vector quantity. As a vector quantity must have a direction. That's why either it will be a clockwise or anti-clockwise. Only two possibilities are there, clockwise or anti-clockwise. Then if two moments are acting in same direction, to find the resultant, we will add them. And if two or more moments are acting in opposite direction, to find the resultant moment, we will subtract. So if we want to find the resultant moment, it depends on which direction the two moments are acting. If they're acting in the same direction, we will simply add them. If they're acting in opposite direction, we will subtract them. I will give an example so you will understand. Example, this is an object which is fixed from the center. Okay, a force of 5 Newton, which is at a distance of 4 meters, and another force of 5 Newton, which is also from the pivot, it is at a distance of 4 meters. If I say this is force A and this one is force B, force B FB, force A FA. Now the first part of the question, calculate the moment due to force A about point C. What is about point C? Point C example is this is a pivot which is also known as point C. So if we want to calculate the moment of force A about point C, so we only want to calculate a turning effect of force A. So what is the turning effect of force A? The moment is given by force multiplied by distance. So force is 5 and the distance is 4. So 5 multiplied by 4, that's equal to 20 Newton meter. And what about the direction? What is the direction of this moment? Clockwise or anti-clockwise? Yeah, that's good. It is anti-clockwise. And another question, the second part, if I say calculate the moment due to force B about the pivot. So we want to calculate the moment of force B. So this, when this force B is applied, which direction it will rotate? In this manner it will rotate. So what is the moment? Moment again, that is force is 5 multiplied by distance is 4. So 5 multiplied by 4, that's equal to 20 Newton meter. And the direction, what about the direction of this? That's anti-clockwise, good. So that is also anti-clockwise. Is it clear, the first two parts? At first we calculated the moment due to force A, then we calculated the moment due to force B. Now the third part, calculate the resultant moment. What is the resultant moment? I mentioned in the beginning that if two moments are acting in the same direction, to get the result, we will add them. So moment of force A and moment of force B both are anti-clockwise. So what is the resultant turning effect? So what we do, because they are in the same direction, so we will add, so it will be 20 Newton meter plus 20 Newton meter. So the resultant moment will be equal to 40 Newton meter. So that is, and the direction of the resultant will be same as the direction of the highest value. But in this case, both are acting in the same direction. So the resultant will also be in anti-clockwise. If the question was calculate the resultant force, so what is the resultant force? In terms of when we check force, we don't bother about the moment. Force A, FA is acting downward, 5 Newton, and force B is acting upward, 5 Newton. So what is the resultant here of the two forces? Force A is acting down, force B is acting up. Two forces are acting in opposite direction. So what will be the resultant force? It will be 5 minus 5. So resultant force will be equal to 0 Newton. Is it clear about the resultant force? Because the two forces are in opposite direction. One is downward, another one is upward. That's why we subtract. But because the moment, the turning effect produced by both forces were in the same direction, that's why we were adding it. Is it clear, this example? So if they ask for resultant force, you will only check the force. If they ask for moment, resultant moment, so you have to check the turning effect, because the turning effect of both forces is anti-clockwise. That's why it is anti-clockwise. Another example, a similar example. Look, about the resultant force, you don't have to bother about the moment. In the previous example, as you can see, I mentioned one of the force Fa was acting downward. Like if I say on the object, one of the force is downward, 5 Newton, and the other force was acting upward. So what is the resultant force here? One of the force is downward, the other force is upward. So what is the resultant force here? Because the two forces are in opposite direction, so it will be simply 5 minus 5, that's equal to 0 Newton. If two forces, because force is a vector quantity, if they're acting in the same direction, we will add. If the forces are acting in the opposite direction, we will subtract. So another example, I will use the same numbers now. Fa and Fb, both are 5 Newton and at a distance of 4 meter from the pivot. So if a question is calculate the moment of force A. So how we calculate the moment? The moment is the product of force and distance. So this is a turning effect. The force is 5 multiplied by the distance is 4. So 5 multiplied by 4, that's equal to 20 Newton meter. What is the direction here? So 20 Newton meter, it will be anti-clock. And if we want to calculate the moment of force B, or the turning effect of force B, so the force is 5, distance is 4, that is also equal to 20 Newton meter. But what about the direction? Which direction it will try to cause a... So a force B which is acting downward, so which direction it will try to cause a moment? So it will try to cause a moment in a clockwise direction. And if we want to calculate the resultant moment, so one of the force is causing a clockwise, another one is causing an anti-clockwise. So the result will be 20 Newton meter minus 20 Newton meter, because they are in opposite direction. The moment this turning effect was 20 Newton meter, the other side also it's 20 Newton meter. So what happened? This object will not rotate, or its turning effect will be 0 Newton meter, or this object will not rotate, or it will stay as it is. But what about the resultant force? So when we calculate the resultant force here, as you can see, the two forces are acting. When you calculate a resultant force, you don't have to check the distance here. So two forces are acting in the same direction. Both are acting downward. So what is the resultant force? It will be 5 plus 5. That's equal to 10 Newton downwards. Is it clear, this example? To everyone? Resulting force, Abdullah, means result of the force. If, for example, if I say, as we did this in the effect of the force example, Abdullah, if I say, I want you to use the mic so you can answer my question at the same time, Abdullah Sarfraz. Abdullah,
Yes, sir.
look, example, a force of 5 Newton is acting towards right, and another force of 5 Newton is also acting towards right. If I say, what is the resultant force? What is the result of these two forces?
It will be plus.
We will add them because in the same direction it is 5 plus 5. So we take 10 Newton. Same way, if an object is there and one of the force is acting down, another force is acting up. So 5 Newton force is down, 5 Newton is up. So what is the result of these two forces?
0.
0. So the resultant force will be 0. That I did in the previous example, that resultant force will be 0. Same thing, if two forces of 5 Newton acting in the same direction. So when we are finding the resultant force, we just check the object and the direction of the force, not a turning effect. So both are acting downward. So what is the resultant force here? Both forces 5 Newton are acting down. What is the resultant force?
10 Newton meter.
10 Newton, because it's a force, so force is Newton. Newton meter is for turning effect. When we say the turning effect was there 20 Newton meter, but the force is, the unit of the force is Newton. So if two forces are acting in the same direction, we will add them. If they're acting in the opposite direction, we will subtract them. Is it clear?
Yes, sir.
So turning effect is a bit different thing, and force cause a turning effect. So when you are calculating a resultant force, you check the direction of the force only. When you are calculating a resultant moment or turning effect, you check the overall moments produced by the forces. So the moment unit can be Newton meter or it can be Newton per centimeter. How we can increase the moment? If I want to increase the moment, so what I can do, either I can increase the force or I can increase the distance where I'm applying the force. Because if I increase both of them, I will get a greater turning effect or greater moment. So by applying a higher force, if we increase the force or we increase the distance, we can increase the turning effect or we can increase the moment. So if you have an object, two objects are there of same length. Here's a pivot, pivot. I apply a force of 10 Newton from the distance between the pivot and the force is example 2 centimeter. And another example, the same distance 2 centimeter, but I apply a higher force. Example, I applied 50 newtons. Which one will produce a greater turning effect, greater moment, A or B? So B will have a greater moment, greater turning effect, because it will be 50 multiplied by 2. That's equal to 100. Unit of force is Newton, and unit of distance in this example is centimeter. So the unit will be Newton centimeter. And when we calculate the turning effect here, it will be 10 multiplied by 2, which is equals to 20 Newton centimeter. What about the directions? Both directions will be counterclockwise or anti-clockwise. I am writing in short AC. So if we increase the force, the turning effect will also increase. It will have a greater turning effect. And if we increase the perpendicular distance, we are applying the same force, 10 Newton, but we are applying it from a greater distance from a pivot without calculation. Can you identify which will have a greater turning effect or greater rotation? A or B? Which will have a greater turning effect? So in this example, B as well. Why? Because A is having a shorter distance, example 2 centimeter. B is having a longer distance, example 5. So 2 multiplied by 10, that's 20. And 5 multiplied by 10, that's 50. So B will have a greater. Yeah, total length is same. That's the good question, Abdullah, that they have the same total length. But the point where we are applying a force, that will decide the moment. Here, we are applying a force closer to the pivot, and in the other example we are applying a force away from the pivot. That is why when you see the door handles are always placed far from the point at the end. Like example, if a door is fixed from this side, this is the fixed side or the pivot. So where the door handle is placed, they are not placing a door handle in the center, they are placing a door handle at the other end. Why they are placing a door handle at the other end? So that this will have a greater distance from the pivot, so door can be easily rotate or turn, or we can produce a greater turning effect. If it was placed at position B, then we have to apply a greater force to rotate this door. And you can practice this, like you can apply a force, try to open the door from the end, or try to apply a force and open the door near the point of a contact or pivot. You will find that this point C will be difficult to open the door as compared to point A. Is it clear, the idea of how we increase the moment? So we can increase the turning effect by increasing the force or by increasing the perpendicular distance from the pivot.